Hello everyone, welcome to Simplified Geometry. Today we are going to learn Theorem 6.5 of lines and angles. The theorem states that if a transversal intersects two lines such that a pair of interior angles on the same side of the transversal is supplementary, then the two lines are parallel. Let us understand this theorem by looking at this diagram. Here, line L is the transversal. It intersects the lines M at point P and also intersect line N at point Q. We are concerned only with the interior angles formed here. So what are interior angles? Interior angles are those angles formed between these two lines. So angle 3, angle 4, angle 5 and angle 6. These four angles are enclosed between these two lines, are inside these two lines M and N. These angles are inside these two lines. Now, what are interior angles on the same side of the transversal? Let us look at the left side. In the left side of this transversal L, we can see angle 3 and angle 6. So this will form one pair of interior angles on the same side of the transversal. We can call it short as co-interior angles. So angle 3 and angle 6 will form one pair because they are lying on the left side of this transversal L. What about the other pair? Angle 4 and angle 5 are on the right side of this transversal L. So this will form other pair of the co-interior angles. So we have written the pairs of co-interior angles. Let me say it once again. It is angle 3 and angle 6 will form one pair because it's on the left side of this transversal L. And similarly angle 4 and angle 5 are on the right side of this transversal L. Now what does the theorem says? The theorem says that if angle 3 plus angle 6 equal to 180 degrees, that means they are supplementary. Supplementary means if we add these two angles, we will get 180 degree. So if angle 3 plus angle 6, the one pair from this, if angle 3 plus angle 6 equal to 180 degrees, then line M will be parallel to line N. Similarly, this other pair also, angle 4 plus angle 5, if these two angles are 180 degrees, then again line M will be parallel to line N. This is what this theorem states. Now let us write that. What does the theorem says? If angle 3 plus angle 6 in this diagram, if angle 3 plus angle 6 equal to 180 degrees, then line M will be parallel to line N. Now there is a shortcut to find this co-interior angles. We can see a C shape forming here. A C shape. So the C shape stands for co-interior angles. Let me highlight that. So this is the C shape I am talking about. So see the C shape. Inside the C shape, look at the corners of this C shape. You can see angle 3 and angle 6. These are the co-interior angles. Okay, you can similarly draw the C shape here also. So inside the C shape, angle 4 and angle 5 will be here, will be there. So, but we have drawn only on the left side, the C shape. So angle 3 angles. You should always remember the C shape. It will be very helpful. Let us take an example. Here line AB is the transversal. It intersects the lines PQ at point C and it also intersects line RS at point D. It is given that angle PCA, this angle PCA is given as 50 degrees and angle RDB, this angle RDB is given as 130 degrees. Now we want to check if the lines PQ and RS are parallel or not. Now let us try adding these two given angles. Let us try adding these two. Let us see what will happen. When we add these two given angles, we just saw something interesting. So angle PCA plus angle RDB equal to angle 50 plus 130 degrees. What is that? It is 180 degrees. So angle PCA plus angle RDB equal to 180 degrees. But We just learned from the theorem that if the co-interior angles are 180 degrees, if the sum is 180 degrees, then the lines will be parallel. So line PQ will be parallel to line RS. That's what we learned from the theorem, right? So we just saw that these two angles, these are actually co-interior angles. These two angles sum up to 180 degrees. So automatically from the theorem, line PQ will be parallel to line RS. So these are co-interior angles. Hence from the theorem, PQ will be parallel to RS. So we concluded that PQ will be parallel to RS. Since this is a theorem, it has a proof. Now let us see why this theorem works by looking at this proof. So let us write the given information. What's the given information? Two lines AB and CD. AB and CD and a transversal PS intersecting AB at point Q and intersecting CD at point R such that one pair of co-interior angles is 180 degree. That is, it is given that angle 1 plus angle 2 is equal to 180 degrees. So what you have to prove? We have to prove that line AB will be parallel to line CD. So we have written the to prove part. To prove that line AB is parallel to CD. So for the line PS, look at the line PS. For the line PS, angle 2 and angle 3 are adjacent angles formed on the line. So angle 2 plus angle 3 will be equal to 180 degree. We will write that here. Angle 2 plus angle 3 equal to 180 degrees. What's the reason? Linear pair axiom. We will denote it as equation 1. But what's given? It's given that angle 1 plus angle 2 equal to 180 degrees. So we'll write the given part again here. We will denote it as equation 2. This is the given information. Now you can see carefully, the RHS is same. Here also 180, here also 180 degree. So what about the LHS? The LHS will also be equal. The LHS will also be equal because the RHS is same, 180 degrees. So we can equate the LHS. So from equation 1 and 2, angle 2 plus angle 3 will be equal to this LHS will also come here, angle 1 plus angle 2. You can see in both sides angle 2 is there. In both sides angle 2 is there, so we can cancel it out. Angle 2 will go, it will cancel. So we are left out with angle 3 will be equal to angle 1. But what is angle 3 and angle 1? These are nothing but the corresponding angles. So we just proved that the corresponding angles are equal. So these are the corresponding angles. Thus for lines AB and CD with transversal PS, we just proved that the corresponding angles are equal. Angle 1 equal to angle 3. Therefore, lines AB will be parallel to line CD. What's the reason? The reason is converse of corresponding angles axiom. So at the end we have to write hence proved.